Assalamualaikum and hi everyone. In this video, you will learn about topic wave resonance phenomenon. So, in this topic, you will learn introduction, types of resonance, characteristic of wave resonance, example of wave resonance, advantages of wave resonance, disadvantages of wave resonance, and conclusion.
Let's look at the video first.
How do people make beautiful music with wine glasses? How do you break a wine glass by singing loudly in front of it? Have you ever watched or heard about shattering of wine glass in an orchestra? If yes, then this is all due to the phenomenon of resonance. These changes in amplitude are caused by an important principle called resonance. The natural frequency of glass or any other object is determined by its shape and composition. If the higher voice hit the resonant frequency of the wine glass, a transfer of energy will occur. However, the full transfer of energy can cause shattering of glass. We heard the word resonance used a lot in physics, but let us take a second to ask what is resonance. In order to explain the word, we first need to be through with the following terms. First, period. What is the period? Period is the amount of time it takes to complete one cycle. Second, frequency. The frequency is number of cycles in 1 second is the frequency of oscillation. Now that we have briefed you with the period and frequency, let us understand resonance in the next session. Now, we look at the definitions of resonance. Resonance occurs when a material oscillates at high amplitude at a specific frequency. We call this frequency as resonant frequency. The dictionary defines resonance as the state of a system in which an abnormally large vibration is produced in a response to an external stimulus, occurring when the frequency of the stimulus is the same or nearly the same as the natural vibration frequency of the system. While physics defines resonance as a phenomenon in which an external force or a vibrating system forces another system around it to vibrate with greater amplitude at a specific frequency of operations. Next, we move into the types of resonance. There are a few types of resonance. First, electrical resonance, mechanical resonance, and acoustic resonance. Electrical resonance. Basically, in an electrical circuit, electrical resonance occurs when the inductive reactance and the capacitor reactance are equal in the magnitude. In some electrical circuits, electrical resonance occurs when the impedance between the input and output of the electrical circuit is almost zero and the transfer function of the circuit is near to 1. In an electrical circuit, series impedance of the two elements is at the minimum and the parallel impedance is at the maximum when electrical resonance occurs. Mechanical resonance. We continue with the mechanical resonance. Mechanical resonance is the tendency of a mechanical system to give a response with a large amplitude when the frequency of its oscillation is similar to the system's natural frequency of vibration rather than other frequencies. Some examples of these types of resonance include pushing a swing, motion of a pendulum, and motion of a tuning fork. In all of these cases, the force applied to cause the vibration should be periodically regulated to match the natural frequency to create resonance. Next is the examples of resonance frequency, which is spring and pendulum.
We continue with the acoustic resonance. Acoustic resonance is when an acoustic system has a wave with matching frequencies with one of its own natural frequencies, it amplifies the sounds. This is acoustic resonance. This is very crucial tool for instrument builders, as in case of many acoustic instruments like string of a guitar, length of a flute, and membranes of a drum use resonators, is also account for hearing ability. Let's look at the video for a while.
Next, let's proceed with the characteristics of resonance. There are three characteristics of resonance. First, resonance produced by an external periodic force whose frequency is equal to the natural frequency of the body. Second, the frequency of vibration is same as the natural frequency of the body, which means frequency of the vibration same as the natural frequency will make the amplitude of the force vibration become maximum. Third, the amplitude of vibration is large. If anybody is made to vibrate by an external periodic force with a frequency which is the same as the natural frequency of the body, it begins to vibrate with a very large amplitude.
Now, let us take a look at the examples of wave resonance phenomenon. A traditional example of wave resonance phenomenon is a swing. With resonance, a small periodic forces like pushing someone in a swing can add up to large oscillations over time because the energy is stored. When you sit on a swing, it swings naturally at a particular frequency. When someone pushes you even with a very minimal effort, it allows you to swing at a greater amplitude. The key is that they push you at exactly the same frequency you did swing it. Resonance is a periodic force syncs up with the natural frequency of a system. Next example is a radio. Have you ever wondered how radio picks certain frequency so you can play your favorite channel? Well, when we turn the knob of the radio to our favorite channel, we are changing the natural frequency of the receiver. The natural frequency of the receiver then matches the transmission frequency of the radio station. When two frequencies match, energy transfer occurs and we can listen to the selected channel. A microwave is also an example of wave resonance phenomenon. The food in microwave oven is heated quickly because of resonance. The radiations emitted by a microwave oven have a certain wavelength and frequency. Like all other objects, molecules of water and fat also have a resonance frequency. At a certain frequency, the molecules absorb wavelengths and start vibrating, causing cooking and heating up the food. That is how we enjoy the food we cook from microwave.
Next, let's proceed with advantages of wave resonance. During resonance, the amplitude of vibration increases very high. The increase in amplitude during resonance has various advantages as well as disadvantages. There are 4 advantages of resonance. First, useful to determine the unknown frequencies. Second, useful to analyze musical notes. For example, we have seen the people who are playing musical instruments are tighten the notes of the guitar and check the stretchiness of the tabla. The ensuring the sound will come from the instrument and account of resonance for listening the melody sound. Third, useful to increase the intensity of sound in musical instrument. For example, all musical instruments create sound by causing matter to vibrate. They use resonance to amplify sound wave and make sound louder. It is easily vibrate at those frequencies and vibrate less strongly at other frequencies. As example, a trumpet increases the amplitude of a sound wave. Lastly, useful to tune a radio receiver to any desired frequency, which means many frequencies from different radio stations are impinging on the radio's antenna at the same time. By varying the capacitance in a circuit, the circuit can be tuned so resonant frequency will equal to the station frequencies.
First, the disadvantages of the wave resonance is affect the injury of car crash passenger. In a car crash, a passenger may get injured due to the phenomenon of resonance. This happens because when chest of person is thrown hard against the seat belt, vibration set up inside the body, and this vibration can burst blood vessels. Second, the resonance of rotor blades of helicopter can harm the pilots. This is because the frequency of vibration sometimes causes resonance in helicopter and also in the pilot's brain and affect their vision, which is fatal to them. Rotation of rotor blades of helicopter can set vibration in the helicopter too. Lastly, the resonance of wave can destroy and break the bridge. In April 1831, soldiers marched in steps across England Broughton Suspension Bridge. The bridge broken apart because when the soldiers marched, they are tapping their feet critically. The tapping of the feet should have own natural frequency. When natural frequency is equal to external applied force, then the bridge will break. We can also see the other biggest same example that happened to Tacoma Bridge in 1940. The Tacoma Bridge collapsed, which happened because of the frequency of wind matched with the frequency of the bridge and leading to its collapse.
Resonance occurs when the natural frequency of a system coincides with any expected force vibration frequencies, which can lead to severe levels of vibration. What can be done to stop or minimize the effect of a resonant condition? In practice, the following rules can be used to shift a natural frequency and minimize the vibration response of a system. The first one is to add stiffness increases the natural frequency. Second, adding mass decreases the natural frequency. Third, increasing damping reduces the peak response but widens the response range. Fourth, decreasing damping increases the peak response but narrows the response range. And fifth, the last one, reducing forcing amplitudes reduces response at resonance. In conclusion, as frequency of external force applied by an object is equal to the natural frequency, the frequency amplitude will be increased. That is what we call resonance. Advantages of resonance are amplification in instruments, mobile phones, lasers, and communication systems. Resonance would also bring disadvantages as it can cause violent motion and failure in improper constructed structures. Effect of resonance can be reduced or stopped by shifting natural frequency and minimize the vibration response of a system.